Hello, I'm Ettocraft, and today I interview the TU Wien Space Team from Austria. Could you please introduce yourselves?
TU Wien Space Team, we think that for a good education, it consists of two parts. At first, the theoretical part, where the university is perfect for that, and second, the practice, where one works on real projects in a real team with some responsibility. And the TU Wien Space Team is one place to do that. The thing we do on a day-to-day basis is building rockets and rocket engines and satellites and stuff. But in the end, we want to have fun and learn a lot. And the way we achieve that is by having really cool projects, because then you get the people to stay in the team. We do all of this in our free time. So if it's not fun, if it's not cool, if you wouldn't learn a whole lot, the people wouldn't stay. And that's you could say that's the reason why we try to have a cool team and really cool projects with huge goals. And how many people are we? I would say about 120 active members, and all of them are like part of the space team, but there are different projects inside the space team. We built a 100-kilometer rocket to reach the Kármán line, which with solid boosters, which is launching in America in the Blackrock Desert. We have already built a liquid rocket engine, which was capable of flying to 3 kilometers, and it was the first to be recovered again in Europe. We also built a larger rocket engine with 800 newtons of thrust, 8 kilonewtons of thrust. I think that was also one of the biggest liquid rockets in Europe. We've built a satellite already. It was a cooperation with some other people from university and so on. Now we built our second satellite, but all by ourselves, so by students. We built a hydrogen plane, which is, it's more of a drone, like 2-meter wingspan, flies with hydrogen and should be capable of crossing Austria, so our home country. It has a flight path of about 400 kilometers, and stretch goal is with a 360-degree camera flying through the valleys of the Alps with a live stream. And then we have some other smaller projects. For example, we're a launch provider for the ESA CanSat competition. We've got a beginners project where small teams are building the first solid rocket. We also built a hybrid rocket, which is quite new and started also as a beginner's project. And that's basically the space team.
The TU Wien Space Team is a quite big association, which has lots of different projects. And I think the common thing about this is the enthusiasm about space and the willingness to fail during hard projects, but continue until they work and really get something to work. And Lamarr is just one of many projects. And there we have the story is basically I'm not quite sure. I believe the drive to build a liquid rocket and to build a better one. Last year we built one, so now we want to have a better one, and a bigger one, and improve on basically every aspect.
How many times did you fail on the liquid engine project? How many problems did you had? A rough estimate.
Not really something you can count. It's a constant thing, and it's more something that you succeed once, and then you fail and fail and fail, but you continue until you succeed again. And every failure you basically learn something, and everything you learn puts you closer to your goal.
You could certainly say this about the Lamarr project and the microhybrid project. I mean, last year in the end at the EuRoC, we were lucky that in the end at the EuRoC competition everything worked out. So this was the one where we didn't fail, but everything worked as planned. So we started and landed again.
So you believe that if you want to learn the best way, you should both go to university in a space team if you're interested in space stuff?
Yeah, I think that's a good way of putting it. It's not like the like joining a space team is the best thing you can do for like your career and well-being and learning. It's also about university. So I think it's like they fit together really well, because universities usually only the theoretical stuff. And yeah, the space team is the complete opposite side. And I think it's a great way to join those two together to get a good technical education as a whole.
I also believe that hands-on experience and just learning with your hands basically is the most important thing, and doing so in a team and not just on your own in your basement. Do it in a team, and teamwork is very, very important, because no big project has ever been done alone.
How did your team start?
It was 12 years ago, I think. There was some student who did an Erasmus year in France. And in France, at that time, it was a much more usual hobby to build model rockets. And there were competition. And when he came back to Vienna, he said, hey, why isn't there a space team in Vienna? So yeah, he formed one. It was just, 10 people. And in the first year, they built a rocket to 3 kilometers solid. And they participated in this competition in France. And since then, each year we went to France for that competition, but slowly, but really slowly grew, like just some people each year. Then we started to build a Cubesat, which was a cooperation with other universities. And yeah, then we started thinking, hey, we don't want to launch to 3 kilometers. Let's try to break the European rocket like flying height, which was at the time, I think 21 kilometers. And in our simulation, it says, hey, we could reach way more than that. So let's try to hit 42, because why not? And then the simulation said, hey, we could reach 100. So the Hound project was born, and we try building a bigger rocket. Big means, I think the lift off mass is 36 kilograms, something like that. It's a 2-stage solid rocket. And yeah, then other projects form. Now we build our second Cubesat. We start building liquid rocket engines. And yeah, basically all of our projects just form usually when we're just like, we ordered pizza and we were talking about some stuff. And then we just come up with like a really dumb idea or some idea, doesn't matter. And yeah, then we just go through it and make it a reality. And I think most of our projects formed that way. And today we're like, we don't just build one rocket, but we've got some really diverse projects. As I said, solid rockets, now also a hybrid rocket, a liquid rocket, Cubesats. We also build a hydrogen plane. And I probably forgot some, and then some other smaller projects like for our beginners. And we are also launch provider for the ESA CanSat challenge and so on. So it's a really broad student club as it is today. And you could say it's about 120 active members, something like that. And so it's not one project with 100 people, but 30 people here, 20 here, 10 here. So it's really broad, a broad spectrum. And the TU Wien Space Team is the thing that that keeps us all together. So we share one workspace, and yeah, we of course meet every week the different projects like by accident, and so we really know each other well, and also can really build upon the experience of other projects, because at the end of the day the problems are really similar, and I think that's also one reason why the space team is doing so well on the long term, because there are so many different people, and we're willing to like ask a lot of questions and build upon the work of the people that came before us. And I think that's one of the main reasons why the space team is doing so strong in the last, you could say, decade.
You have quite a lot of people in your team. I guess that's because you have so many projects. There are many people who are interested in at least one of the projects.
Yeah, so usually when people join, they like join the space team, and within the space team, they join like one project. And join is not like you're registered, but you show up to the meetings and put your time into it, and then suddenly you find yourself in another project, like by accident, and people are in different projects.
One thing I want to add to Patrick's statement is that also it's not a clear line that you have one project and then you swap and then you're in another one. Oftentimes, for example, electronics people often are in multiple projects because they build on this and then on the other project as well. And so there's, many people which are in multiple projects at the same time. So the question, who is where, is hard to answer because everyone is everywhere.
How is it to study in your university?
Our university, most of us are from the TU Wien or TU Vienna, but I think they don't use the term anymore. And there are all the like basic things you can study in the technical university, like computer engineering and physics and chemistry and all that stuff. But we are not too close to university. So most of us are from the TU Vienna, but basically we're entirely separate. We get our workshop from the university and a little bit of funding, but other than that, it's just this is university, this is us, and we get along really well. But it's not like we're part of university, if this makes sense. But still most of us are from the TU Vienna.
It's not even required that you are a student to join. It's whoever is interested in building cool stuff can join.
And oftentimes when people are finished studying, they just stay at the space team. Like they work full time, but I guess space team is too cool to quit just because you work somewhere else.
In other teams, you leave when you finish university, at least mostly when they finish university.
Yeah, maybe because we're not too coupled to university. It's hard to say why. It's just a thing that formed, and I think also compared to other teams, the people or some people at the space team stay really long compared to other university teams. Now I think it's my 5th year, but there are people who are at the space team like for 8 years, 9 years. One guy for 12 years. So it's maybe 2 years on average, I would say. I mean, a lot of them just 1 week and then you don't never see them again. But maybe 2 years is a good average for time spent in the space team, but some way more.
I believe it's also because it's not at all coupled to the university. Because in other teams, I believe that they are have like a requirement to do this for like 1 semester or something, and they just do it for uni, but not out of their own drive. And also a big advantage of this is if you have people who were in the team for like 8 years, they have a lot of experience and they know stuff. And that's just a huge gain if you have someone who already failed at what you're trying now. They can teach you so much.
Yeah, we really value reviews inside the team because, as Georg said, if you ask someone who has worked on a similar project, you can just save so much time. It's like so much trial and error you could save just by asking someone who was in a similar situation.
What job opportunities do you have once you finish university and once you leave the team?
I think at the space team, it's not like too coupled on you want to go to the space sector, then you go to the space team and then you work in the space sector. I think that's certainly the idea with some people, but generally speaking, we could do whatever we want because the space industry is not too big in Vienna. So it's not like there's this 1 or 2 obvious choices for career. I always think like in the space team, we do space projects, but it's not the main thing that you work at the space team at because the rockets are cool, but because it's just a really cool opportunity to learn stuff and the people are cool and we just happen to build cool rockets. But we build rockets because it's so cool that you're willing to spend your free time on it. I think that's the valuable point because otherwise it's so much time. It has to be cool. It has to make fun. Otherwise, you're just not doing it. But but still we are in contact with, of course, sponsors from the space industry and from all the networking events. We just know them really well. So yeah, maybe we get a little bit of an insight into those companies, but I won't say there's not a huge intention for the people in the space team. Now they're at the space team, so that next year they can be in the space company. It's more like when they're finished with the space team, they might eventually study, and then maybe let's see what job opportunities in space there are. So it's not like a how do you say it in English, like a board where you jump upon and then you get access to some contacts in the space industry. So yeah, I think there's not too much of a focus there.
What are your team's goals and your active projects?
Yeah, maybe we start with Lamarr. Georg, what's the goal of Lamarr?
Well, the goal is to participate at the EuRoC23 in the 9-kilometer liquids category. And of this project in particular, there is also a major intention is that we way better documentation than on the last project. Team building is very important to this project in particular. 9-kilometer liquids rocket. We would like that the rocket is below 25 kilogram wet. So including the fuel and the oxidizer. But yeah, that's not a deal breaker if we can't do it, but that would be great.
And yeah, from the rest, yeah, as I said, there are a lot of projects. For example, the Hound, where we want to reach 100 kilometers with a solid rocket. But it's not like the idea, we want to reach it someday, but we already built the rocket that might be capable of doing that. We launched it for the first time 4 years ago. Then it was Corona and there were some years break. But this September, we are again in America in the Blackrock Desert, where we try to reach 100 kilometers. Also, our Cubesat should launch to space next year with ESA Aerospace. Then, as I said, we built a hydrogen plane. Like it's more of a drone, like 2-meter wingspan. It flies on hydrogen and should be capable of crossing Austria. So we've got a route through the country, which is about 400 kilometers, and with 360-degree camera, live stream, and so on, like the stretch goals.
The goal for the space team itself is to foster curiosity in space.
We just try to give students the opportunity to work on really great projects so that they can grow on their technical knowledge, but also their like as a person. And as long as we achieve that, yeah, we use our projects to accomplish that.
Instead, how do you recruit new team members?
It's usually, I think, similar to other teams on social media and networking events on the university. Yeah, we try to get them to our recruiting day, which is basically we are in a lecture hall and talk about why we're awesome for 1 hour, and so that they can get to know the project and what we really do. And yeah, then there are some onboarding days, as we call them, where the people who are interested in one specific project show up at our workshop, and there they get to know the project team closer and maybe already see what they can do with the space team, like concretely. Some people stick, some people not, but yeah, that's totally okay. Everyone can join the space team. I think that's also what differentiates us from other teams. So you say, hey, that sounds cool. I'm willing to like put my time, sweat and tears into it. Then that's just the spirit we need, and everything other that you need, you just learn at the space team.
What can your members learn from joining the team? Is it like something specific, or do they learn like a bit of everything from building stuff to rockets?
I'd say you can learn everything, like from how to use the lathe or a CNC machine, that you learn how to work on something even if you don't get paid and even if it sucks, and to reach a goal, and you want to work with others working through difficult problems.
At a very interesting spot, because it's on the one side all the technical stuff you can learn, of course. Mostly because we build basically every part of all the rockets and so on ourselves. So the technical stuff you learn, but also, as Georg said, working on different problems. It's much more than that. It's working as a team and managing so many stuff and having an idea and just going with it. So having an idea and then just trying it out. I think that's also one thing we value. When you've got an idea, you just do it. It's like you you go to the workshop and try it out, and if you fail, that's a good thing, because then you can iterate on that. One thing that you don't learn at university: the way of reaching a goal is always fixed. Like when you get an exam, for example, there is a specific goal and a specific way how you should reach that goal. But now the space team, we are the ones who make the goals and are much more free of how we want to achieve that. And I think that's a thing you have to unlearn from university. Unlearn, that sounds too harsh, but I think you have to learn outside of university.
How do you design? What process do you use to design it?
Yeah, that's quite easy. We ask the question, is it really necessary to reach the goal? And then most of the time it's no. And then we have a special other question, which is, but is it cool? And then we say mostly yes. Then we have to figure out if it's cool and stupid or if it's cool and smart. And if it's cool and stupid, then we try to argue until it's cool and smart, or we eliminate it and we try to keep it as simple as possible. But then there are always people who come up with, we have to figure out if it's a smart idea as well. That's the decision process. Does it make sense? No. I mean, apart from the fact that we're building model rockets, because that makes no sense. Building up from there, does it make sense to reach our goal? No, then keep it away. Leave it. We don't need it. And yeah, this is the way to go. And we have basically everyone has to decide for themselves if they think it's smart. And then we have like modules where every module has to decide for themselves. And then, the fundamental question is, does it make sense? Or do we need it? And if not, leave it away.
We like to talk about our design process. It just sounds so don't know, at first stupid, but the thing is, it works, and it works so well. We go with what seems to be like cool and fun, and we need those two things, because otherwise we won't do it in the first place. So it's hard to say, but it works, and I mean the results speak for themselves. I mean we launched a liquid fueled rocket and recovered it safely, and I think we were the first to do so in Europe. So you could say, it works.
Also like the third lightest rocket at the competition or something like that. We eliminated so many parts that there was not much weight left.
How much did the micro-orbit rocket weigh in the end?
13 kilograms, including fuel.
Like lift-off mass?
Yeah, lift-off mass.
With mass,
yeah. Including the payload.
Including the payload.
Lift-off mass. So the vehicle itself was 12 kilos with fuel.
Yeah, it's very light. Remember, it was quite small.
Because if you make it smaller, it weighs less, and if it weighs less, you need less fuel, so it makes everything easier.
And it's also cheaper, because you need less carbon fiber, less fuel.
It's way cheaper, and also your requirements for recovery are easier. If your rocket weighs half as much, it's less of a shock, it's less parachute you need. It makes the parachute smaller. It makes the rocket smaller because the parachute is smaller. So yeah.
So it's basically simpler to make a smaller rocket up to a certain point, because if you need to machine very small parts, then I guess that would be more complicated.
It is hard to decide which parts you can leave away, because oftentimes you believe that you need something, and then if you think about it really hard, you realize there is no point in having it. It's really hard. It seems like such an easy question, but it's not. It's really not, because oftentimes you have some idea or some belief that you need it, but if you really think about it, you realize you don't. You can see it in many other rockets that they have parts which are not necessary. That's the hard thing. The decision to leave stuff away, even if it seems like a good idea.
Instead, what is the rocketry community in your country? How many rocketry-related things?
I mean, there are some companies from the aerospace sector, but I guess not too many. But as for the experimental rocket community, I mean, there's a second team, the ASTG, Aerospace Team Graz, for some years now, a space community or experimental rocket community, except us. I mean, last year, some people from the space team found a startup. Now they are building rocket engines for satellites. So it's called Gate Space. But besides that, no, there's, I think, no experimental rocketry community besides us. I feel like I miss someone, but
it seems to me always like if there is something space related, people turn to us. Even the Technical Museum in Vienna comes to us when they want to talk space, they come to us.
In general, it's so fun how many people write to the space team, because if you need something about space or knowledge or something, you turn to the space team. I think that's kind of funny. Last year, even some theater wanted to talk to us because in a play there was an astronaut which was landing in the Danube, and we were like consulting for them how this could be and so on. And in the end, a colleague and me, we played a part in the play. So we became part of the theater, and we were on stage. And don't know, there are just a lot of people wanting to like talk to us because yes, space is cool, I guess. But also from different countries, like every other month, some space team in Europe ask us, hey, how are you building this and that because of your projects? And have you got any tips when you want to go to EuRoC and so on? So yeah, I think it's kind of cool that so many people turn to us for information.
Ted, where do you test your rockets and where do you launch them?
The launching part is, I think, the hardest because in Austria it's really hard to get permission to launch a rocket. We've got one rocket launch a year in Austria for the ESA CanSat competition. But this is so much work to get this right every year. Besides that, yeah, we launch in Germany, also in Poland. We've launched in France, Italy, Portugal, of course, America. And the hardest part is the height which you can launch to. I think this is the one thing that is keeping us back now, but also in the future. But I think all of the rocket teams in Europe, because in Europe you cannot fly higher than 10 kilometers, like easily. And so it's hard to say, hey, let's build a rocket that is capable of flying higher, because if you cannot launch it, flying higher isn't too hard. I mean, we launched 100 kilometers, but don't know, you cannot launch higher. I think that's so frustrating. I think that's keeping a lot of teams back.
How do you promote your team? How do you make people know that your team exists?
As I said, mostly social media, Instagram and so on. We also go to networking events at university where there are a lot of students. We've got a YouTube channel. Yeah, just all the basics stuff. Word of mouth and here and there in newspapers and so on, and the radio sometimes. So depending on, if people ask, we usually say yes when it means that we get outreach and so on. So yeah, but mostly we try to reach students from our university, and we do this at the networking events and on social media. What
are your experiences at EuRoC?
It was very stressful, but great. I think last year decided to go to EuRoC because it's a hard deadline. And we wanted the project to finish. Then when we were there, it was just an overall great experience to see so many great people work on rockets and see their rockets and have them look at your rocket and launch there. And it was just so fun and stressful because we weren't prepared well enough. But yeah, it was great. We want to have this experience again. There's a shop with all sorts of stuff close to Pontesora, which was it's called Happy Shopping, and it is Happy Shopping. And we want to go there as well.
Yeah, when George pitched the idea to go to EuRoC next year, I was like, this year, 23, he was like, why should we go to EuRoC again? Because of Happy Shopping, because it's just such a fun experience. And it was basically the reason he presents to us. And we want to build a 9-kilometer rocket. So yeah, you can see his passion.
What are some of the biggest challenges you faced for designing, building, assembling the rocket for EuRoC?
Biggest challenges have not arisen yet. We most likely have a problem with time. So the biggest challenge to date is choosing the correct glue for our tank, for our oxygen tank, and getting our test stand tank to be leak-free and all the nitty-gritty stuff. engineering stuff. I mean, there will be more challenges. And how will you ensure that your rocket is safe to launch and operate during the competition? Tests. So, yeah. But that's tests and some calculations, but tests.
What do you want to achieve during EuRoC?
I want to see the rocket launch. I want to see it recover. I would like to enjoy the competition more than last year by being better prepared. Everyone else would agree on some level. We had a test launch last year. We won't make one this year. We probably won't have time in this short amount of. Yeah, there's not much time left, and we need to build a 9-kilometer rocket. So yeah, and simulations. Yeah, everyone has to do simulations. That's part of the.
Would you like to join other competitions like Space Cup America?
Right now, there's no reason to, because of, there's the EuRoC. So EuRoC is just cheaper, and the focus is more on Europe. Other than that, I don't think there are a lot of competition beside of EuRoC and the Spaceport America. I think one valuable thing about competitions is that there's, as Georg said, a deadline, and you get to know other teams and other projects. And I think talking to the other teams, it's just so cool because we share a hobby and passion for something, and I think that's a great thing. But are there any other rocket competitions?
I believe there are some smaller competitions, for example, in Poland, but the main two are definitely EuRoC and Spaceport America.
Talking to other teams with the same hobby, basically, but they always have a fundamentally different approach. Even if we look at Graz and the ASTG, their approach is so vastly different to ours, and that's also very interesting to see. And then last year, one team I have in mind really is Bath University and also UCLA. They just had so vastly different approaches to basically the same problem, which was just so interesting. And to see this and go to those competitions and then go back and then design a completely new rocket with those approaches in mind is, I think that's just really enriching.
How do you think that rocketry will evolve in the future?
A change that you could see in the last couple of years is that more teams are starting to build liquid rockets. For some time, there was more the focus on hybrid rockets, or like in the past, mostly solid rockets. I think that's a cool change. That more teams are building liquid, and I think in the future we'll try to have a space race again, but with liquid rockets. Some of the teams will have to solve the problem how to launch higher than 10 kilometers in Europe, because I know you can go to other countries, but not every team can finance that. So I hope we see another space race, but with liquid rocket engines in Europe. I don't remember the name. I think they built a hopper already.
In Switzerland they built one, and I want to see more hoppers.
That would also be cool,
And it solves the problem of the height.
How do you finance your team?
Mostly financed by sponsors. Basically, when we see something that is cool or something we need for a rocket or a satellite or and so on, we just write an email to some company and say, hey, we are the space team, you're super cool, may we have this and that? And most of the time they agree. And that's our, I would say, main way of funding.
One thing that doesn't really add to the question, but if you really are interested in doing it, before you send an email, do a phone call. They are much more inclined to do it when they talk to you. That's a great tip for everyone who wants to do this. Great hint.
And I think it's also easier nowadays because we already have a big portfolio of stuff we achieved and are working on right now. So it's not like we built our first rocket and see the renderings. This is what we want to build, but we built so much stuff that it's, you could say, easier to believe us that we're like really pulling through stuff. How much does it cost to build a rocket? Don't know, George, what does it cost to rebuild Micro-Hubble 3-kilometer liquid rocket last year?
The costs are hard to say because the workshop is for free and can be considered as for free, and then the tooling we have, and so basically just materials and no no labor time or labor costs. I think it was 3,000 euros or something. So it's basically nothing. It's you can't really say, oh, for 3,000 euros you get a new rocket, because you need to have the infrastructure and the people doing it, and every part has already been built once, so we know to do it, and we had tools and so on. So yeah.
So for us, it's 3,000 euros in bare cash flow, and the rest comes from the team.
Yeah.
But I think that's the upside of building everything ourselves, because I think just some few exceptions, but other than that, we just build everything ourselves. And I think I've watched some other interviews with some other teams, and I think all of them said, hey, it's really cheap, but it's always depends on what you compare it to. Budget for the entire space team with all the project maybe comparable to rockets of other teams. I found that quite surprising.
What softwares do you use to design and simulate the rocket?
Whatever does the job best. It's so many things. So for testing the engines, we have our own software, which has been developed over, I think, 4 years. For simulating, we mostly use Python, but we used MATLAB in the past. We use ANSYS, we use SolidWorks, the FEM simulation. We use KiCad, Slack, OpenRocket, RocketPy. There are probably lots of things. There is a tool to design antennas. I have no idea how it's called. There's so many things. For the engine itself, we have the Open Rocket CEA, and then there is also a NASA online calculator, and lots of stuff. But it's all publicly known. I think we don't have. We have a couple of scripts we wrote ourselves. For example, we called it EuRoC, which means Open Rocket Liquid Engine Generator. So it generates an engine file for your liquid engine. So you can just import it into OpenRocket.
Yeah. So what sensors do you put on your rockets?
Yeah, we have custom PCBs. It is ST. It's STM32. Sensors. For the rocket stuff, we have an IMU and a barometer and a GPS. Cameras, we had cameras, but they didn't work. And for the propulsion side, we had temperature sensors and pressure sensors. The pressure sensors are important to basically see if the rocket is in a safe state. Or on the last rocket, it was like this. On a new rocket, we also regulate the pressure in the tanks. So we need the pressure sensors to know that, to be able to do this. We also measured the combustion chamber pressure because the chamber pressure correlates to the thrust. So basically, with the chamber pressure, we knew, by measuring the chamber pressure, we can decide, or we can see if the engine's startup worked correctly. So we only release the rocket when it's safe to.
How do you recover the rocket?
Last year, we had a clamp band mechanism, which was actuated by a commercial line cutter, but they were quite expensive. So now we decided that we want to have a clamp band system, which is easier to test repeatedly, or cheaper to test repeatedly. So we opted for a burn wire method. So basically the clamp band is shut or held closed by a loop of, I think, nylon wire. And then we have a resistive wire, which, when current goes through, it burns the nylon and the clamp band is released. That's for separation at apogee. And then for main deployment, this time we'll have a spring actuated bolt, basically, which releases also with a burn wire. So if the burn wire cuts or burns the nylon, a spring releases. You use bright colors for that. Yeah, CO2 cartridges or other solutions, or black powder. It's just, it's black powder or pyrotechnics. They are just dirty, and we're not in the Middle Ages. And CO2 cartridges are just too many parts for the task. You don't need it. It's too complex. We use rubber bands to separate. I forgot to mention this. I think that's just so much more reliable and safe and lightweight. And Do you use bright colors for the rocket and parachute for easy locate after landing? Been decided yet which colors, but most likely. So we'll have 2 different colors for the 2 chutes, and I'm not sure if the rocket itself will have a bright color because it's so small you can't see it anyway. I think we will make it pretty. I'm not sure. I believe, even though I'm the project manager, I don't have to say. The people who are designing it they can decide on their own, as long as it's pretty at the end.
What payloads do you put inside the rocket?
Put 3 CanSats in there. One of them will be in line with the shock cord, and will be able to measure the shock of I'm not sure if it's already decided if it's the main shock or the drogue shock, but it will measure the shock because we put lots of effort into calculating it, and it turns out that calculating the parachute shock is quite hard. Now we opted now we want to know what it is and not just calculate it and hope for the best, but also measure it. So that's why 1 CanSat will be used for this, and the other 2 CanSats are for the winner of the Austrian CanSat challenge. They will come up with something interesting, but we don't know yet. Today we have a meeting with them, and we'll talk about an interesting solution.
Do you know Kerbal Space Program?
Lots of people said as soon as you start playing it, you can't stop. I bought it, and then I promised myself that I stay away from it because I know that it would take up too much time. I'd rather build real rockets at the moment, but I most likely will.
Basically similar. I don't know if I'm allowed to say this, but I also haven't played it. But once I got it for free because some website gave it away for free and someone was posting it at the Space Team channel, and there I got it, but I haven't installed it.
Okay, I said
yet.
I did the same thing.
Mostly because of time reasons and so on. It's just.
Does your team have any announcements or things they want to do in the future?
Just the things we want to achieve in the next year or 2. Like finally launching our 100-kilometer rocket, or bringing our Cubesat to space, or crossing our country with a hydrogen plane, or launching to 9 kilometers with a ethanol LOX liquid engine, and maybe also flying our hybrid rocket. But other than that, I think there are no big team announcements for now. So let's see what happens after the EuRoC, what our plans are after that.
What are your personal plans for the future?
Finish studying.
Same.
Right now, that's the main goal. Like this year will be my last year as president of the space team. And after that, finish studying. And then, let's see what will be my new role in the space team, because I will certainly stick. But career-wise, let's see. That's not the right time for me to think about that. I think today I'm at the space team, and then I'm going to study.
I'd like to say basically the same thing, but insert project manager or project lead instead of president. But everything else is the same. Let's see what the future holds.
Do you have any advice to young rocketeers?
Over the years, a lot of new student clubs reached out to us, and the thing that comes up the most often is to start small and to iterate. At first, it's easy to say, hey, let's build a rocket and fly to 10 kilometers, or to reach space to 100 kilometers, and then design the rocket for a year, and then just build it a little bit, and then it's 2 years before you launch your first rocket. And I think it's really hard to keep the motivation up when it's just like theoretical stuff, and then after 2 years you launch a rocket, and then it crashes, and it's 2 years, and you've got just one rocket launch. So our main advice is start small, build a rocket next week, not next year, because small rockets is like a rocket that flies to 1 kilometer solid. You could build that in a few weeks, because there you learn so much more compared to a design phase that lasts a year.
What are your favorite space movies or YouTubers?
That's a great question. I'm a little bit more of a fan of the more, like, not too distant future, like you could say more of the realistic type of movie. I mean, I also love like Star Trek and Star Wars and so on, but I really like The Martian. And okay, Artemis, there's no film about that. I think that's just a book for now. Gravity, I think, is also a really cool film. And yeah, most of the time it's easy to just point at the things that are not, like, could not be real or physically not too accurate. But yeah, I think it's always cool when they are giving their best. And yeah, I like to feel that this is something that could actually happen. And yeah, for YouTubers, TU Wien Space Team has a really awesome YouTube account. You should give this one a look. And yeah, also, yeah, Everyday Astronaut. I really love the longer videos. Scott Manley, like just the main people you already know. In Germany, in October, I think there's a meetup with all the space YouTubers in Europe, and yeah, we will probably also be there and meet all of them. And yeah, looking forward to this.
Do you have any questions for me?
Like, how do you see your role in the space community? I see you're really active on LinkedIn and you're doing the interviews and stuff. Yeah, I think that's really cool. Also the Space Launch Initiative. But how do you see your role in all of this?
Well, I don't know. I think I will probably start a team. They actually have started a team, but it didn't really work out. Probably should try again. I'll probably make my own space team and, make rockets. Don't really have many plans after that, like what a job I will do. But I guess for now, just to make rockets, maybe make more interviews to learn stuff.
What kind of rockets are you building?
I made solid rockets and a liquid, very simple liquid rockets, basically the simplest you can get. I haven't tried hybrid rockets. The reason is that I don't really have a good oxidizer, so I'm using air. There aren't many solid things which would be good for a hybrid rocket that uses air as an oxidizer. Wax wouldn't work. Sugar wouldn't work. I guess I could use paper, maybe. but I'm not so sure about the energy it holds. Probably the fire will just go out. Yeah, for sure, solid rockets were the easiest and the only ones that I made that could fly, except for bottle rockets.
If you're working on a liquid rocket already, then I don't know, this is just a personal preferences. But if you already work on a liquid rocket, yeah, do you need a hybrid rocket?
Yeah, I'm not a very big fan of hybrid rockets because with a hybrid rocket, you're less efficient than a liquid rocket, but you have some of the complexities of a liquid rocket, like valves. Not so interested in making a hybrid rocket. However, it would be easier to make a hybrid rocket. You only need one tank. So maybe in the future, I will make a hybrid rocket. Like if I want to make a rocket that flies, that is in solid fuel, I will probably go for hybrid first. As my liquid rockets that I've done, if I just use the air compressor as a rocket, it would make like over 10 times the thrust just by shooting air.
Oh.
So, but at least I can cook some marshmallows very fast.
That's also nice, yeah.
Probably one of the few rockets that you can safely put a marshmallow into without risking.
Yeah, I think we already also put a marshmallow on it, but there was nothing to eat because there was no marshmallow anymore after the hot fire test.
I don't eat the marshmallows either because like after 11 seconds, it's half a marshmallow and the part that remains is carbon. It's even with just air and ethanol, the flame is quite hot. It's over 2000 degrees Celsius. And it makes me ask how it's possible that my 3D printed nozzle made of PLA could last like 11 seconds before they melted.
Wow. Where did you measure the temperature? Like inside the chamber?
No, I didn't shove anything inside the chamber. I didn't actually directly measure it. Well, okay, so basically I have two ways. So first, when you just burn ethanol with air, normally it reaches a bit like 2100 degrees Celsius. And then by how fast the marshmallow got burned, it's I can say that it's over 1400 degrees Celsius. So not very sure that it is 2000 degrees, but I assume that it will be 2000 degrees as a rocket. I believe a rocket would have a higher temperature than just a flame.
Okay, so it's an indirect measurement. You could say that you've taken it.
I didn't actually put a probe there. Yeah, because the problem is if actually the probe gets to the temperature of the flame, then the probe would probably melt, except if I get some good heat-resistant probe.
Yeah, I think we also don't measure the heat. Yeah, because how should you measure it? I mean, we measure pressure and so on, but the temperature, yeah, that's hard to say. I think we got a little stickers which you can put on the combustion chamber, for example, and then it changes color depending on the temperature. But I think they max out at, I think they max out at a couple of 100 degrees. So, okay, no, that's not enough.
Yeah, the marshmallow is probably the easiest way to measure temperature.
You could measure the infrared light with this
I've got an infrared thermometer and it reaches up to 800 degrees. So I could put a piece of iron instead of then measure its temperature.
Yeah, that's a start. Or you can just point it directly into the nozzle, don't you? Because you just measure the light.
I mean, I could. It's not that I don't really want to risk melting my thermometer. Yeah, it makes quite a lot of heat, this engine. Even if you're at over a meter behind the exhaust, you still do feel quite a lot of heat.
So you just stand 1 meter away from the exhaust and feel the air? Or?
No, I'm at the side of the rocket. Because I need to hold the air compressor's gun, so I need to be less than half a meter.
Okay, yeah.
So I'm by the side. So it's
were you able to measure some thrust?
I mean, it's less than 1 gram probably, but I actually don't know. I know it's less than 10 grams because otherwise I would have felt it on the marshmallow. Because I'm holding the marshmallow with a stick, so I would feel a force on the stick.
Okay, yeah.
And so if it was a kilogram of frost, I would feel quite a lot of force on the stick.
Mm-hmm.
Of course, it's not a kilogram of frost. I think I'm gonna make a proper fuel injector in the near future. As right now, I'm just pouring ethanol into the engine and using the combustion chamber as a fuel tank, which works a bit.
Yeah, that's how you start. Better to start small and have a working engine than, as I said, planning for a year and then it doesn't work and then you have to replan everything. Or what's your goal with the engine in the next, say, year?
My goal is for V2 to be better than V1.
That's the good goal.
Because I basically have no idea about anything of the engine. I do not know the pressure. I do not know the temperature. I don't even know the size of the throat. I know it's somewhere, but it's over 8 millimeters of diameter, but I don't know. I don't know the angle of the nozzle, so I can't really calculate anything. Nor can I really guess accurately what I should expect. I can't calculate the thrust if I don't know the pressure and the temperature and how the nozzle is made. In future, I think I'll make the rocket go on a rail and see if it moves. It won't be a very scientific test, but if the engine makes more than 100 grams, it would definitely move. So I could just see that. Or I could continue using the marshmallow.
Also, you mean on a vertical rail, with rail buttons, and then if it's able to lift itself, it's 100 gram.
I don't know if I want to make it vertical or horizontal, because with my design, so previously my rockets only worked if I put them vertical. So I put them horizontal, I wouldn't be able to ignite them. I put them vertical and they worked. Instead, this latest rocket is the opposite. It wants to work horizontally, not vertically. So I don't really know. Horizontal would be easier. Also because I wouldn't have to make a heat shield, not to damage the floor. Maybe it would be good to make a heat shield so that I could put it in the exhaust and use it to measure the frost. Because right now I'm holding the rocket with basically the air gun of the compressor. So it would need to make quite a bit of force before like a scale would measure it. So maybe it would be better to put the force sensor in the exhaust, protected by like a heat shield.
Maybe to scale it up first and then try to start measuring it?
Yeah, I definitely would like to feel some force on the marshmallow before I start making a test stand, like a proper one. Like having a good fuel injector, have it work both vertical and horizontal. I don't really know why it works horizontal or vertical. It shouldn't really change much because it's not like the ethanol drips out when it's vertical. Also, I would like to get some good ignition system. Since right now I'm working on making a flyback driver. It's a type of transformer to make high voltage. I guess I could use it to make an arc to light the thing. Because I have a piezoelectric button that makes an arc, but it won't ignite. It didn't ignite the previous rockets. However, this last rocket is easier to ignite, so I don't know. But I would prefer to have something more powerful. Because more current goes into an arc, the hotter it is. So the piezoelectric starter probably doesn't have much current in it. Or maybe isn't that long enough to heat up the ethanol around it.
Yeah, so there's not enough heat overall, or how do you say?
Or I could I have a steel wire, which is thin. I could just put it inside of the rocket, send like 12 volts, make it heat up until it's incandescent, and then it should like...
We also, yeah.
Wait, what do you use?
Once we used how's it called? Spark plug, something like that?
Yeah, there's spark plugs, there's glow plugs.
Yes, also glow plugs from car engines.
Yeah, then it's a spark plug. So it makes a spark, like the piezoelectric thing, but it's probably higher power, and that starts it. So I could make that, but instead of having a single, like a spark that stays on for like a millisecond or less, if I use...
that's so short.
If I use like a flyback, then I can leave it on for like 10 minutes, and it should ignite the engine eventually.
But you said you already tried to start a group of people building rockets?
Oh yeah, I made a rocketry team in the closest university to me, and it started working. There are basically 0 active members in the team right now. There is still the server,
but if they started a team afterwards, then there's a team, but it has a different focus.
I didn't hear anything about them. It was going well. We even tried launching some rockets.
Yeah, I guess that the beginning is the hardest.
Yeah, also because if you have at the start you have few results, so people aren't really motivated to keep going. Because if you have like a team already for a year, then you see, okay, last year we made a rocket that went to EuRoC, then we can make another one this year. We already have all this stuff. As at the start, we haven't really done anything, so there isn't much evidence that we can do something else.
And like the infrastructure and generally the knowledge in the team.
And if you have to buy a lathe, for example, well, you don't have a lathe. That can be a problem, of course.
I guess there are maker spaces.
Yeah, there are maker spaces. We can ask like a local school with a lathe to make a part for us, or reverse access the lathe. But still, it would be slower. And yeah, again, people who may not know of these schools or maker spaces may think, okay, how are we supposed to make a rocket if we don't have any tools?
When we started, like 12, 13 years ago, they said they had a few €100 budget from some company. The rest of it got sponsored. And they got a competition of some sort. And from the competition, they got the rules and the deadline and some reports you have to work on. Maybe then it's easier to, when there's an external thing that it's driving you, so you're not all alone by yourself. But yeah, as we said, there are not a lot of competitions besides the EuRoC and Spaceport. Yeah, I think that's really cool. Also, the Space Launch Initiative.
The Open Launch Initiative, giving a chance for everyone to launch, especially there were people who wanted to go to 100 kilometers. If you want to launch to 9 kilometers, then you just go to EuRoC and no need for an Open Launch Initiative. If you want to launch to 100 kilometers, then you can't go to EuRoC to do that. You're going to the Launch Initiative if you want to launch to 100 kilometers.
What are the plans for the launch initiative?
The first thing we should know if you want to organize, because first you see where to launch, then you ask the people who own that place, if you can launch there. And then you do the rest, like setting up stuff there, maybe inviting teams to go there, launching rockets, and getting money, because the launch sites for 100 kilometers aren't free.
I guess finding the site is the most difficult thing, because I feel like if there's a place where one could launch, then all the teams which want to launch there, they put like the time and the effort into it. But for us, we would love to have a place to start 100 kilometers, but we do not know whom to ask. I mean, in like Kiruna and stuff, there you could launch, but it's too expensive. So I guess that's not an option to talk to them.
Yeah, the too expensive part was actually one of the motives of the Open Launch Initiative, because the idea is when you grab the rocket, you disassemble it when you transport it. So you need to then assemble it there. So you need to pay for like a week at the launch site. But you can make like 5 teams launch in the same amount of time, because everyone needs to prepare their rockets. And so then you have that like each team pays a fifth of the price that they would pay if they went alone. And that was one of the reasons for the Open Launch Initiative. I don't know what's the price, but I think it was like over $10,000.
Yeah, I heard in Sweden something about 70,000, but those numbers might be old.
But still, hard to get for a new team. Hard to get for any team, really.
There was one team like 1 or 2 weeks ago. They launched to, I think it was high end. They launched to 60 kilometers, something like that. Hybrid, probably. Do you know where they launched? I think they launched somewhere in Sweden.
No, I don't know where they launched.
Because I guess there's the DLR. It's from Germany, some association in space. And I think they fund some student teams. And I could guess that they paid the fees for them, but I could be super wrong.
If I remember correctly, they were building, I don't know if they're still building it, a launch site, a spaceport in Norway. And it would be within the Arctic. And you could launch up to 100 kilometers there.
But are they building it for like commercial use, probably?
From, I believe that you can like go there and launch if you pay. It's not like only for companies. At least I believe it's not only for companies, but also a space team or multiple space teams could launch there.
But I like the idea of it's too expensive, but if there are more teams, we could split the costs.
I mean, if there are more teams, we would need to stay there a bit longer, but probably still everyone would pay less.
I mean, for example, when we go to America, to the Blackrock Desert in Nevada with our Hound rocket, like the 100-kilometer rocket, we prepare, I mean, there is no infrastructure. We prepare the rocket in an Airbnb, and after that, we drive to the desert for some days, and we work inside the RV. So like the how do you say it? Like the cars where you can sleep in, the camper vans. Don't know, maybe that's a way to save time there, so that we don't need it for a week, but say 2 days.
Definitely need more time to make 10 teams launch than for one person to launch, because even if the assembly time is equal, because you have more people working on more stuff, then still the launch time is going to be 10 times bigger if you have 10 times the teams launching, or about 10 times longer. Some teams will launch faster than others.
Yeah, but 10 teams sounds like a lot.
I think that there were like over 20 teams that wanted to join. So it would be more than 10 teams. It would be basically like EuRoC, but you can launch to 100 kilometers. And not will there be a competition.
A one-off thing where you do it a little smaller, and then you will like learn from it and maybe do it bigger. Because if you do it for the first time and then 10 teams and a week and a lot of money is maybe too much. Maybe there's a way of doing it like a, don't know,
maybe
team.
The first time you would do it less. Though, on the other hand, if you have more teams, there are more teams to share the price. Again, probably the first time would be slightly more expensive, probably, because it's not so well organized. You might need more time and stuff and you wouldn't be well experienced for it. You didn't have much experience doing that, so there might be costs you did not expect there to be.
Maybe there are people that we could ask for help. For example, the DLR from Germany.
Did it with Astra Bremen.
Ah, yeah. Mm-hmm.
Actually, it was, the idea came up during my interview with them. But they thought of organizing it because they want to launch 100 kilometers. They wanted a launch site for 100 kilometers. And they said, well, other teams want to launch 100 kilometers. So how about we launch together and save money?
Or maybe one could ask Copenhagen Suborbitals, like Lars, if he has some idea whom to ask. Because it feels like we don't just call the company and say, hey, we would like to launch and split the cost, but more of we call it and say, hey, we're student teams. Could we do like not a special price kind of thing, but like some events where pay less than for commercial use because of education, because of students. Students have not a lot of money.
The price is to rent out the area. So I don't think they really care how many people go there. So you rent the area and then you can like do whatever you want there. You shouldn't destroy it, blow it up. But basically, except that, I think you can do whatever you want.
Yeah, we already launched 100 kilometers, but in America, in the desert. And there it's like, I think it's $50 to launch there. I mean, today we know how to do it because we were there 3 times already, but yeah, it's also expensive and mostly organizational work.
Yeah, and you don't have the problem of recovering at sea. Thank you for joining me in this interview. For anyone watching, like and subscribe. So thank you. And I guess that we can say bye.
Thanks for having us.
So thanks for the interview, and I'm already looking forward to see the results. Thanks. Bye.
Bye.
Bye.